Christian's introduction. We owe our existence to our large, bountiful oceans. But could similar oceans exist on other worlds? Could they contain life? In his speech, Christian takes us on a journey across the solar system to the deep oceans of Europa, where alien life may live closer to home than we think. With his speech entitled Alien Oceans, Christian Pearson. Timer 5 to 7 minutes.
The warm, sunlit, tropical waters of the Galapagos Islands are a paradise for life. But over 2 kilometers down, nestled deep on the sea floor, lay a mystery. In the 1970s, scientists took great care to study the area because of its volcanic activity. On one such expedition, while dragging sensors across the sea floor, they noticed a strange anomaly. Some areas of the seafloor were much too hot. Alvin, a US deep sea submersible, was dispatched to investigate. Alvin descended into the darkness, 6,500 feet. That's 2,000 meters down, far below where light does not penetrate. After several hours of exploring, the Alvin team radioed back to the ship above to say that they had found the source of the temperature anomaly. The headlights on Alvin illuminated huge, spewing material coming out of the seafloor. At this depth, though, the temperature was cold and the pressure was over 200 times that of the surface. So this gas coming out of the ground was not gas, but fluid. It actually was hydrogen, methane, hydrogen sulfide. The Alvin team had discovered hydrothermal vents. The submersible drew closer and it started to notice something odd. There were movements on the surface of the vents, strange white shapes. In fact, there were animal communities living in this inhospitable environment. Scientists have been able to trace the history of life on Earth back to its origin in the ocean. And although we don't know precisely how life began, it may have something to do with places like hydrothermal vents. Why? Because it has 3 ingredients for life: energy, organic material, the building blocks of the chemicals of life, and most importantly, water, the solvent of life. But there is another world in this solar system that contains these elements. On a clear winter night, looking out into space, beyond the moon, you might see a faint white light. This is the gas giant Jupiter. Now, Jupiter orbits on average about 780 million kilometers away, about 5 times the distance from Earth to the Sun. And it takes light 45 minutes to reach the system. So from here, we see Jupiter coming towards us, and its 4 largest moons are visible, as first seen by Galileo hundreds of years ago. And today, we are visiting one particular moon, Europa, the ice moon, with a striated surface, smooth and white. Now, this moon is special because it's heated by Jupiter's massive gravity, pulled on like a ball. From orbit, you can see its striated surface with streaks all over, almost like a billiard ball. And in fact, it is the smoothest object in the solar system. The ice shell on top sits aboard a global subsurface ocean. How do we know there's an ocean there? Aside from gravitational measurements, there's also this strange red material on the surface. Thanks to spectroscopy, which is the chemical signature of atoms and molecules by bouncing light off them, we were able to determine that this material is probably salt, magnesium sulfate, sodium chloride mixture. This may be from the ocean beneath. So to date, there hasn't been any actual mission within the surface. But I want to take you on a hypothetical journey. What would it look like if we were to land on the surface of Europa? What might we see? So going into the blackness of the ecliptic, we see a rocky, icy surface. And beyond the rolling hills, we see Jupiter rising up above us, its radiation intense, but blocked and insulated by the ice below our feet. In order to get through this ice layer, we have to drill. Just like an Antarctic borehole, perhaps kilometers down, we would need to dig. Anything we send would need to be lowered carefully through this hole. What would we see if we go through? Perhaps an ice cavern with temperatures 4 degrees Celsius, just below that of freezing, but thanks to Jupiter's massive gravity, warm enough to explore. Descending further, we can send a submersible perhaps into the inky blackness, and light only penetrates several hundred meters into water. So the majority of this subsurface ocean, perhaps 80 kilometers deep, deeper than any ocean on Earth, would be pitch black. What wonders might we discover in this darkness? Would the question of are we alone finally be answered? Most likely, if anything's down here, it would probably be microscopic, but even the discovery of a single alien microbe would change biology forever and would change our perception of our place in the universe forever. Seeing Jupiter with your own eyes through a telescope for the first time is a stirring experience. Those worlds in space that no image can capture beam directly into your eye make you feel the sense that these worlds are as real as Earth. They're places we could stand, that we could visit. Just like Earth, there are unexplained mysteries at the bottom of the ocean. But what mysteries lie at the bottom of Europa's? Perhaps an exploration mission would reveal the answers to the age-old question asked by every generation, with undiminished wonder, are we alone in the universe? Madame Toastmaster.